Welcome to Train Signal. You're watching the Wins concept video for Windows Server 2003. In this video, we're going to take a look at several concepts related to Wins and also NetBIOS, and just to explain and give you a better feel for how these concepts fit into a naming structure in Server 2003. Let's take a look first at our first concept, which is the Application Program Interface, often referred to as an API. Now, this is somewhat confusing, I've found, when going over this with students, but the API is the interface between programs and protocols that connects everything together. APIs allow for a modular operating system instead of a proprietary one. Okay? NetBIOS and WinSock are APIs. Now, let's kind of break this down and try to figure this out a little bit better. An application program interface, let's go back up here, sits between programs and protocols, and basically what we're dealing with here, think about it from this perspective. If we write an operating system, we want to write it in a modular fashion. Okay, and I'm talking about, when I say write it, I'm talking about programming this operating system to make it work. And what's going to happen then if I do this in some sort of, compatible fashion? Different developers for external software companies, let's say for email software or fax software, all sorts of different software, they're going to be able to develop programs that interact and are modular with Windows 2000 or Server 2003 much easier because they have this common interface to write to. Okay, so that's why we use an application program interface, just to make sure that when we're dealing with programs, the operating system, network protocols, all this stuff works together nicely. Now we're going to move forward into this next concept because it still fits back here in our first concept, the API. NetBIOS is one of the APIs that we're dealing with when we're dealing with Windows. Okay, and NetBIOS is a legacy application program interface. Okay, and you can see here that it's used in legacy Microsoft operating systems, which is anything really pre-Windows 2000. So this is going to be NT4, Windows 95, Windows 98. Okay, all of these are pre-Windows 2000 operating systems, and they're considered legacy at this point. Now, NetBIOS, what this means then, in these operating systems, this is how these systems interact and talk to each other when they're on a network. Okay, this is the programming interface that's used for these particular operating systems to communicate. Okay, so if a Windows 95 machine were looking for an NT4 server, it's using NetBIOS in order to find that server. Any programs that are written for NT4 or Windows 95, they're going to be using this NetBIOS application program interface. Starting with Windows 2000, they went to a more compatible, universal application program interface, WinSock. Okay, and WinSock is short for Windows Sockets. Okay, Windows Sockets. And this is what's used in 2000, Server 2003, and Windows XP. However, NetBIOS is still very important because this application program interface is still very prevalent. There's a lot of networks that still have NT4 servers, Windows 95, Windows 98. Okay, so we can't just cut off support for NetBIOS. Okay, what would end up happening here, if we cut off support for NetBIOS and we only supported WinSock, Windows 2000, Server 2003, and XP systems wouldn't be able to communicate with those legacy operating systems. Okay, so this leads to this point here. It is still enabled by default in both Windows 2000 and Server 2003. Okay, so NetBIOS is still around. It's still being used on Windows 2000 and Server 2003 networks. It's on by default. Okay, so works on top of assorted protocols as well, including NetBEUI and TCP/IP, and that's kind of what we're going to talk about next. NBT, or NetBIOS on TCP/IP. Okay, and it says here, allows for NetBIOS name resolution to take place on a routed network. Uses a combination of broadcasts and name servers. Now let's try to describe what's going on here. Okay, first off, we started talking about before NetBIOS and WinSock, and we've talked a little bit now, and you should have an understanding that these are two different application program interfaces. It's kind of like two different ways to accomplish the same thing. Okay, so let's just look at it from that perspective. We're just trying to set up a simple network. The old way of doing it was using this NetBIOS API, and the new way of doing it is using the WinSock API. Okay, so it's really, in the end, accomplishing the same thing. It's just choosing one direction or another direction to go. Okay, and newer operating systems, 2000 and later, are using WinSock. Okay, now when we're using either one of these, NetBIOS or WinSock, what we like to do is use easy to use names. Okay, so for example, instead of a computer trying to communicate using a MAC address or an IP address, we like to use names that are simple, like server 1, XP1, or even some name that relates to where the computer is located in a network. Okay, so when we're doing that, what has to happen, we need some way of resolving those names back down to IP addresses. Okay, so if we give simple names to all the different computers in our network, for example, the system that we're looking at this video on right now is named XP1. Well, when a computer talks to this machine, another computer, a server, another XP machine on the network, it's not going to refer to it as XP1. It needs to get down to the IP address and the MAC address in order to be able to communicate with this system. Okay, and that's where these, the process that we're going to go over in this series of videos comes in. Now, NetBIOS on TCP/IP. Before we had TCP/IP, we were using a protocol called NetBIOS, and you may be somewhat familiar with this just from working with Windows 2000, Server 2003, and reading assorted books. But NetBIOS is not really a very prevalent protocol anymore. When Microsoft networking was first introduced, NetBIOS was the default, and it served its purpose. Okay, the problem with NetBIOS, however, it doesn't work on routed networks, so it's really only useful on very small networks. And the way it worked, basically was computers broadcast out and indicated that they were on the network. So if you're trying to communicate with XP1, your computer would broadcast out shouting for XP1, basically, is there any computer on the network named XP1? And your computer named XP1 would then respond, yeah, that's me, and send back a MAC address basically saying, here's the address where you can reach me at. Okay, and then your computer would talk to XP1 by using that MAC address. Well, now we're using TCP/IP almost exclusively, on our, not just the internet, but also our company networks as well. And we still need to support NetBIOS. Okay, so NBT or NetBIOS on TCP/IP really is just referring to, the same old NetBIOS API, but now let's make it work with TCP/IP. Okay, and this allows for NetBIOS name resolution to take place on a routed network. Okay, and it uses a combination of broadcasts and name servers. Let's talk about what this means a little bit. Okay, first off, when we say a routed network, this just means a network that has routers in it, and it's separating out different segments of a network. So if you're not that familiar with the routing concept, we need to place routers in networks, just as a rule of thumb, anytime we have more than 200 or 250 computers. And a routed network then allows us to separate out those two network segments to make them more efficient in network communication. Okay, so if we have a larger network, let's say over 200 computers, it's very possible that just plain old NetBIOS is not going to work. Remember, broadcasts do not pass through routers, so on a larger network where we have TCP/IP, we're going to need some other way of resolving names. Imagine this. Okay, you're trying to talk to XP1 and you're on another segment. Maybe you're even in a remote location and you're trying to talk to XP1. So your computer broadcasts out, it's shouting out for XP1, okay, but you don't get any response back. Okay, and just to give you a better visual, picture that we just have two locations like we do with Wired Brain Coffee, what this whole course is based upon. They may have a location in Seattle and another one in Spokane. Okay, well, if your computer's in Spokane and XP1 is in Seattle, when you broadcast out looking for XP1, the router in between those two different remote offices is going to block that broadcast, and there's going to be no way you're going to be able to talk to XP1 using the old style broadcast. And that's where name servers come in. Okay, and this leads right into our next topic. The NetBIOS name server, NBNS, is the acronym there. Okay, and a name server is just basically a machine that resolves NetBIOS names to IP addresses. And in Microsoft parlance, this is a WINS server. Okay, WINS is the Microsoft solution to this problem. Okay, and what this basically is, to sum up this whole WINS server, well, it's just a database of all the different computers in your network and their IP addresses. So now when your computer in Spokane wants to talk to my computer in Seattle, what it's going to do now is go talk to the WINS server. Instead of shouting out and broadcasting and having that broadcast blocked by a router, it's going to go out to its pre-configured WINS server and say, hey, do you know the IP address for XP1? Now that WINS server is going to return back an IP address, the one that's within its database, and now your machine is going to use the IP address directly to talk to XP1, and that will work over a routed network, unlike the broadcasts. Okay, so that's in a nutshell what a Win server is for, and we're going to spend a lot of time focusing on that throughout this course. Now, our last concept is the LMHOST file. Okay, and this is a small file found by default on Windows operating systems. It's located in the system root. Okay, and this is just an abbreviation essentially, because a system root can be different depending upon what operating system you're running and also where you choose to install your operating system. On this computer, and remember we're sitting on an XP machine, the system root is on the C drive and it's in a directory called Windows. Okay, so we could just substitute C:\Windows here, and then you see that it's in the system32 drivers etc directory. Okay, and we're just looking for a file that has no extension named LMHOST. Now, an LMHOST file, this was used prior to the NetBIOS name server, and it's still used today for troubleshooting, but it's not really that common. And we'll take a look at the LMHOST file, but it's very similar to the host file that you may have seen in DNS before. And it's just a basic text file, and it has names of computers and their associated IP address. So the concept is here, if I wanted to, I could put a fully loaded functional LMHOST file on this computer and not even use a Win server. For example, I could have the IP address for server 1 and the IP address for server 2 and the IP address for XP10. Any computer I want, I could put that information inside the LMHOST file and save it locally on this system. Now, it's going to be much quicker. We're not going to have to go out and talk to the Win server. The problem is it's very difficult to keep this file updated. And if you have many systems on your network, you'd really hate to have to go around to each different system and also keep this file updated. So that's why it's not used too frequently anymore. Just so you know where it's at, let's go take a look at where we can find it. Okay, so we're going to go to the system32 drivers etc folder. So I'm going to my computer, opening up C, and here's my system root, like I talked about before, and this is the default system root in Windows XP and Server 2003. It's the Windows directory on your C drive. Okay, now I'm going to go down to drivers. Actually system32 first. Okay, then I go down to drivers. Then I open up this etc folder, and now you see the exact path right here, okay, to find this LMHOST file, and here it is. Okay, now the LMHOST file can be edited just using a simple text editor like Notepad. So I'm going to go to Open With, okay, and then just pick out one of these programs, and the one we'll use is just the Notepad program. Okay, so now when I open this, you see that up top we have all this information from Microsoft, and there's some instructions. This is very helpful information and something that if you're modifying the LMHOST file that you definitely want to pay attention to. Everything with the pound sign over here is basically remarked out, is what it means. And that means that it's not read when the computer is trying to read the LMHOST file. Okay, so it's just kind of remarked out. It's just there for your information. So the first valid line is actually down here, and there is nothing in this LMHOST file by default. Okay, so the LMHOST file here, something to make a note of, is blank by default. You can see that every single line is remarked out. Okay, so we covered in the LMHOST file what a NetBIOS name server was, what NetBIOS over TCP/IP is, and this is just in contrast to the initial NetBIOS API, which was typically run with NetBEUI. And then we also talked about what an application program interface is. So these concepts all tied together can really help you out when it comes time to get a better understanding of how WINS works. Okay, that wraps up our WINS concept video. We'll see you back here real soon when we get started with the lab setup and then get right into Lab 1 and the actual training.